everyone, and today we are going to solve this LeetCode daily challenge. Minimum cost to make at least one valid path in a grid. So in this problem statement, you want to go from cell 0, 0 to cell n minus 1, m minus 1. So to go from this source cell to this destination cell, you are given some directions and some valid path would exist. So given the directions, if some valid path already exists, then the total cost of going from cell 0, 0 to 0 to n minus 1, m minus 1 will be 0. And if there is no valid path, like there is no way to reach to this destination cell, then we can switch some directions. And switching those direction will have a cost of 1 unit. So in overall, you want to tell the minimum cost. Like if you are doing it without switching, then the minimum cost will be 0, and if you're switching something, then there would be some cost, and in those costs you want to find the minimum one. So what you can do is, like from a single cell you can go to 4 directions, like north, south, east, west. And what you can do, if you're going in a direction which is mentioned in the cell, then the cost will be 0. And if you're going to a direction which is not mentioned in the cell, then the cost will be 1. So you can create a graph uh, of like connecting these nodes in 4 direction, and the weights will be, like if you're going in the same direction mentioned in the cell, then the weight will be 0. And if you're going in a different direction mentioned in the cell, then you are technically switching, so the cost will be 1, so the weight will be 1 for that edge. And after constructing that graph, you can find the shortest path. And since the graph is directed and weighted, you can use Dijkstra algorithm, and the weights are also constrained there to 0 and 1, so you can also use 0, 1 BFS. But like I'll solve this problem using Dijkstra because I came up with that solution. So yeah, we should start coding. So how are we going to do that? First of all, calculate the size of the grid. So now you can create an array for those directions. Like 1 will say that you're going to right, 2 will say that you're going to left, 3 will say that you're going down. So construct it on the basis of these numbers. Okay, so yeah, I'm going to create a vector for it, and right, left, bottom, top, and you can create an adjacency list. So this is how you will create it. Now you traverse the whole grid and construct the graph first. So what you're going to do is, when you're on a cell I, j, you want to visit all 4 directions. So there are total 4 directions, and you can find the new index to which you will go to. So it will be something like this, and for j it will be j plus dirs. You also want to check that these new indices are inside the grid. So if ni is less than 0, or ni is greater than equal to n, or nj is less than 0, or nj is greater than equal to m, then we are technically outside the grid, so we don't want to process it. But if we are inside the grid, then we also want the cost. And how will we decide the cost? If the direction mentioned inside the grid is equal to the direction to which we are going to, then the cost will be 0. Otherwise it will be 1. And finally you can update your adjacency list with this ni comma nj and cost. So this is how you will do it. So your adjacency list is constructed. Now you want to apply Dijkstra on this adjacency list. Basically we have constructed the graph and now we want to apply Dijkstra algorithm. So how are you going to do that? First we will have some variable called infinity, and what are we going to do? Like initially all the vertices will be at infinite distance from the source. So we'll create a vector to store the distance of each node from source. So let's call it d. It will be of size n comma m, and each of its value would be equal to infinity right now. And you will also have a set to store the node which is at minimum distance from the source. You can go through the Dijkstra algorithm once before uh, writing the solution for this. Now first the source will be at a distance of 0 from itself, and we'll also insert this into the queue. And while the queue is not empty, what we are going to do is we will get this vector from queue, we will get the indices, and then we will erase this node. Now we will go to all the nodes adjacent to vi comma gi, and after doing that we will basically get this this in the adjacency list, and from this 2 we will extract ni, nj and cost. So 2i will be 2 of 0, 2j will be 2 of 1, and cost will be equal to 2 of 2. Now we will relax the array, like if d of vi comma vj plus cost is less than d of 2i comma 2j, then yeah, the for 2i 2j, d of vi vj plus cost is a better answer. So we'll remove the previous node 2i 2j which was present in the set, like if it was present. If it is not present, then erase will not work, but if it is present, it will remove it. So we'll just remove it, and we'll update this with a new value. What will be the new value? This d of vi, d of vj plus cost. This will be the new value, and we'll update it. So finally you can return the shortest distance. I think this solution should work. There can be some compile time errors. Yep, I knew it. Okay, I rented these angle brackets. Yep. Since this is Dijkstra algorithm and we have used set to implement it, so yeah, solution is submitted. So this is Dijkstra algorithm and we use set to implement it. So its time complexity would be, I think so it will be v log v plus e. So yeah, the solution will pass. V is in grid terms, the v is equal to n into m. So n into m log nm, so something like that will be the time complexity. And if you use BFS 01 BFS, I think you can optimize it more, because then you don't have to use this uh, set. Set is basically a sorted queue. So in 01 BFS, we always know that the answer will be increased by 1 or it will remain same. So we will manually maintain a queue and manually try to maintain it sorted. We won't use in simple queue, the insertion and deletion operation would be O of 1. So yes, that block term we can then remove. So yeah, thank you for watching this video. I hope you like it. Please hit the bell icon for any notifications and also subscribe my channel. So thank you.